okay for flame? No, we have to give hydrogen. So hydrogen and zero air is a fuel for FID. That's why we are using this. All are connected. Here it is coming, that means this percentage was big of hydrogen. Then this is the valve pipe, valve on. That's why I am going to more of this chromatography. The liquid oil is taken from the transformer. We check where some acids are there or not, hydrogen are there or not. So much that from refinery gas, that is called RG, refinery gas. After 30-40 seconds, you can press start button. Your loops part will be injected. If you inject from 30 minutes, 40 minutes, no, it's only 1 ml will be injected. 1 ml here. That loop size can be changed according to application. Here 1 ml is okay because your sample is all are in percentage level. Most probably methane up to 80% in your sample. So that is 1 ml is okay. But I want to detect acetylene in ppm level, or I want to detect hydrogen in ppm level. We have no option. The FID cannot detect hydrogen, ECD cannot detect, only TCD can detect hydrogen, and we want to detect 100 ppm hydrogen. So we have to inject a large volume of sample. So that time I can change the loop. We have different size loop. We will test first with 1 ml loop. We will see if there is any peak in 100 ppm hydrogen. No, we are not getting any peak for hydrogen. Okay, we will increase the volume of sample. So we will change the loop to 2 ml. Now we will try with that sample. Now we are getting a very small peak of hydrogen. Okay, 2 ml is okay for that. Or we want to get a clear peak, sharp peak, more area. Then you can increase up to 3 ml. You can increase up to 5 ml. But not more than 5 ml, because column has some capacity. You cannot inject very large volume inside the column. Up to 5 ml can be injected. You want to see the valve? That valve I. So this is there is 4 pack column inside it. I will show you. If you want to inject with a syringe, bladder or any separate container, you can directly inside from make a adapter and you can use that inlet. It is very less. Point actuated with the air. Yes. What is inside the methanizer? Nickel catalyst. What is the precondition of methanizer to work with methanizer? What are the preconditions? There should be hydrogen flow and the temperature would be above 350. Then only it can convert. Without temperature, it cannot, the reaction will not happen. See, these are the valves. आप आ गए क्या? ठीक है, मैं निकाल रहा हूँ. तो मैं जस्ट आप लोग देखिए 4 मिनट एक. So if you are injecting sample, the sample go through this loop, fill the loops, purge the existing content inside the loop. Then when you press the start button, the loop parts will be injected. Okay. And the outlet bubbles will confirm that your sample is going inside. Injection time is 15 to 20 seconds. So it's a multi-channel. You see multiple loops are there. When you press inject, this loop part will be going to TCD, this loop part will going to ECD, and separate way. In a single injection, so we can use multiple detectors. 3 detectors can be used at the same injection. Please come. This is the column. Column details will be seen. PPQ, PQ. It cannot separate oxygen and nitrogen. Poor separation for CO and CH4. And the inside column, inside the oven is molecular sieve. It can separate oxygen, nitrogen, hydrogen, oxygen, nitrogen, and the elution order is methane first, then CO. And if you use only this column, they are CO first, then methane, and separation will not be clear. It's a compromised separation. These all valves beyond 2 lakhs cost. All are air actuated valves. This is methanizer box. There is inside one tube contains catalyst, nickel catalyst, and also we are giving hydrogen. Without presence of hydrogen, this is not possible to convert CO and CO2 to methane. At the same time, it will produce H2O, water also. That water will go to FID, and there will be no peak, no effect. Nickel. Yes, nickel catalyst. What is the working temperature of methanizer? Above 350. Up to 400. Okay. We will give 390 degrees centigrade. Why? See, in gas chromatography, temperature is always good for GC. If you use higher temperature, your column and other components will be cleaned, because we don't know, in our sample maybe some other gases may be present, their boiling point, other liquids may be present, their boiling point will be very higher, and it will take time to elute. So if you increase the temperature, their velocity will be increased and that will come out. But it should not disturb our analysis. We have to take care. Which one is methanizer? This one. Yes. Don't touch. This is above 300 degree. Can you show me the loop, sample loop? Which loop is filled? This one? This one loop? Right?
No, this is
column.
This one.
This one is
Okay. So show me the molecular sieve column.
molecule.
Which one is molecular sieve column? आप इधर मत ढूंढिए. Yes. Show me. Open the door. Ma'am. Show me ECD, electron capture data. Which one? This one? This one ECD, electron capture data? Confused. This one. This one FID, flame ionization detector. There is a flame inside, right? To ignite the flame, which are the fuel gas? Mix of oxygen nitrogen called zero air, and only oxygen is okay for flame? No, we have to give hydrogen. So hydrogen and zero air is the fuel for FID. That's why we are using this cylinder, hydrogen cylinder, and this one is air. The color will say you, red color is universal for hydrogen, and full S color is for zero air. It contains oxygen and nitrogen 20:80. This is nitrogen, black and S color combination. This is also used for carrier gases. we will use this carrier for ECD line. And for TCD and FID, we will use argon as a carrier. That if you use nitrogen as a carrier, you will not get nitrogen peak, because always nitrogen will be there, na? Your sample contains very small amount of nitrogen will mix with your carrier gas. So you cannot get separately nitrogen peak. You have to keep it in mind that whatever you want to use as carrier gas, your sample should not contain that. So what are the carrier gas? You can tell me the names.
Nitrogen,
Helium,
and
Sometimes hydrogen.
hydrogen also.
Okay.
What is
Valve. These are valve.
why we are use 4 valve?
One valve is for injection, sample injection. One for CSB column switching valve. One for bypassing methanizer. We can decide our sample should go to methanizer or not.
Okay.
If my sample is contains very high amount of CO and CH4, that is definitely give peak in TCD. So no need to use methanizer, because methanizer will be consumed. Very high amount of CO2 and CO2, it will convert very high amount of methane. So our methanizer consumption will be higher. So that time we can bypass.
Okay.
This is bypass valve.
Okay.
And this valve is for injecting, separately given for injecting into ECD line.
Okay.
So one is for injecting sample to TCD line, one is for CSB column switching valve, one is to bypass the methanizer, and one is for ECD line. Notebook or pen. Code valve here, right? 1, 2, 3, 4, 5, 6. Right? Before that, we have to do the 4 pack column. And 2, 3 MS molecular sieve column. 4 is going to TCD. Right? After TCD, it is going to methanizer, then FID. So this is TCD, and the TCD outlet is taken here. It is going to this methanizer, then again from methanizer to FID. Okay? All are connected inside. TCD one side will be open, this is reference side and this is analytical side. We need to balance these two sides. Before injecting any sample, both side resistance is 25 ohms, 25 ohms. Once you injected any sample, that sample's thermal conductivity is different and it will create a difference with your reference side. That difference is measured and it is converted into peak. And in GC, you know, it's a dynamic in nature. Nothing is stable here. You inject, that sample will be carried by your carrier gas, will go to detector and going to outside. So it will disturb for some seconds. And that time you will get that raised peak. After that, in different integration time, all other components will come. Now one by one, it will give peak. So in this series, in this system, so your combined hydrogen O2, N2, CH4, CO will move as a packet and CO2 will come later on. Let them go. Here packet H2, O2, N2, others, and CO2 will come here. Let them go. Hydrogen will move very fast. If this column is very small in length, so then hydrogen will move here, and it will give a peak in TCD. Then other gas O2, N2, CH4, CO and CO2 will now come into border. So we can get hydrogen peak at the first event. All other peak will be trapped. CO2 can be moved here, can be pushed from here, and you can get CO2 peak, hydrogen, CO2. After CO2, you can off the valve, and these 4 peaks can be eluted one by one. O2, N2, CH4, CO. If this column length is shorter, then we can take the hydrogen first, and oxygen to CO can be trapped here. then CO2 can be eluted from here. After CO2 elution, these 4 can be released. Okay.
Sir,
This is the model 2. Model 1, all the component can be trapped here. After releasing of CO2, all the component can be released one by one. That time you can get hydrogen peak here. Right. That's model 1. Model 2 is you can get hydrogen peak first, then CO2, then others. Model 2. Model 3. If this column is much more shorter, then we can elute hydrogen, O2, N2, then trap CH4 and CO, then remove CO2 from here, then release methane and CO. Model 3. So many models can be used, depends on column's length. If my molecular sieve column is very lengthy, that time all the components can be trapped. You can release CO2 first, then release these components one by one. Okay. This is model 1, model 2, model 3. 3 models can be used here. Here we are using this model, model 2. Depends on this column length. At the same time, the same sample going through methanizer and FID. So at the same time, we can get some peaks in FID also. If CO2 in percentage level, so you will get peak in TCD. At the same time, you will get very large saturated peak in FID. Because it's converted into methane and FID sensitivity is very high, that peak will go beyond my capacity. So that time you have to delete this peak, take only this peak. Why I told delete peak? Unwanted. You cannot report twice of a single component, right? You have to report only one. But it is possible that you can get 2 peaks in different detector of same component, because it is detecting in TCD, because in percentage level as the same converted into methane, and now it is detecting in FID. So which one to report? Obviously TCD, because FID peak will be saturated, which converted into methane and with a high responsive detector. So FID, why FID is kept? To detect low BPM concentration. I have calibrated accordingly. So that time you have to delete this peak. If you are getting 2 peaks, both are not saturated, what to do? Which one to report? Only one peak to report.
FID?
Still, I will go with TCD, because we have calibrated TCD percentage level. Because here it is coming, that means it is percentage level. So we have calibrated this is percentage level. This one is calibrated with ppm level. So it will tally better. Okay. So in this chromatogram, you will see what happens. We have injected one standard. Here is the model 2. CO2 is coming here. CO2 is very less in concentration. 100 ppm. So you are getting very small peak of hydrogen. Then this is the valve spike. Valve on. We have released CO2. That means we have bypassed the CO2, not entering through molecular sieve, only Porapack CO2. Then valve off. Oxygen, nitrogen, methane. There is no CO in our standard, so CO peak is not coming, or CO is in ppm level. So here CO should come, but TCD is not detecting because it is in ppm level, maybe 100 ppm. So CO is not coming. See, oxygen, nitrogen, CH4 is there. After CH4, CO should come, na? Right? So now we will check FID or with the of same component, same mixture. See, here this peak is saturated. CO2 is saturated. It is converted into methane, and this detector is calibrated for ppm low concentration level. That's why it is in percentage, so it gets saturated, table shape peak. So you are not able to get the proper area of this peak because we don't know where it should meet. So we will delete this peak. We will take this one only. right? And hydrogen peak is not coming here because hydrogen is not detected in FID, it is not hydrocarbon. CO2 is converted into methane, now it is detected in FID. Then oxygen, again it is not hydrocarbon, it cannot be detected in FID. Now nitrogen even it is not hydrocarbon, so it is not detected in FID. Now methane is detected in percentage level, that's why it is detected in TCD, and in FID it is saturated because very high amount of methane, and this is hydrocarbon, that's why it is detected. Now time for CO. CO is very less concentration, it is not possible to detect in TCD, that is converted into methane, now it is detected in FID. See that 100 ppm CO is converted into methane, now it is well detected in FID. This is possible.
Sir,
That's
for
why.
For the publication, both the results is in
Yeah.
the paper. For the publication, both
Yes,
the,
yes, you have to attach both the chromatogram,
Both.
and in the report you have to report only one side.
That is TCD or FID?
Here you are not getting any peak in TCD,
Yes, yes.
so you have to report in FID.
Yes.
For methane is saturated here, and we will report if it is in ppm level for FID, right? That's why we have deleted. So if you go to the report designer, you can see report will look like this. Two chromatogram there, detector TCD, this is FID, these peak are deleted. In chromatography, deleted means the baseline is deleted, so that area cannot be calculated. Excluded, in chromatography peak deletion means exclusion. Don't expect that this will be straight line. If it is
in the
straight,
explanation part, you have to describe these things. The saturated on this.
no, nothing to describe, everyone knows. You are giving report. This is internal machineries. If you want to test your blood, what they give? Only numbers. They give
Number
you
will change.
chromatograms, anything. So you can give only result also. If you want to give the chromatogram, then you can give, then you have to explain. If someone asks you, then you have to explain. So if you are able to explain, then you can give that chromatogram. If you forget all these things after leaving, give only this.
You can give supporting data.
You just simply
Question
ask your
Deleting a peak means you have to delete the baseline. In chromatography, there are two peaks. So if you add the baseline, then only you will get the area.
Yes, sir.
If you don't add, there is no baseline, so that area will not be calculated. What is this? No. So in chromatography, if you want to delete only, you will be able to delete the baseline. You cannot make it straight line like this. If you make it straight line, then it's a crime. You have to show. And you are excluding. Why you are excluding? You will be able to explain in that situation. That's why I am going to core of this chromatography. Okay, you have to explain. If anyone asks, only when you give that chromatograph. Okay.
Application in the light stage.
Now it is configured for gases. Which gases? Hydrogen, oxygen, nitrogen, methane, CO, ethane, ethylene, acetylene, and in percentage level of H2S. Now you can decide these are my gases. Within these gases, that can be now you can decide which type of with the applicability of your bioscience. You have to decide this gas can be detected in ppm and percentage. Now you have to decide because I don't know your study materials, what are the things, but I know normally in this type of lab people do biogases and ECD. There are some you can do some pesticides. Yes. Actually, this type of gas we are getting PO from this type of institute that we want to do this analysis. So accordingly, we will make a GC. because before
Customized.
getting the order, we are getting some components named and their possible concentration. Accordingly, we have configured. Now you decide, other than this, it can be done or not. Well, I already told you these gases can be done. If your sample contains these gases, you can use it. Because GC is a very vast application instrument. Very vast application. So many institutes and industries use GC. You have different applications. Like transformer, power sector, power plant. They are big transformer. There are some insulating oil inside the transformer. They regularly check health of this transformer by extracting the gases inside the insulator liquid. That liquid oil is taken from the transformer in a gas extraction apparatus. That dissolved gas is being extracted from this liquid, and that gas is injected into GC to check whether some acids are there or not, hydrogen are there or not. This combustible gases are present. That means within very few months that transformer may be blasted. So they regularly check with the GC system. This is called DGA, dissolved gas analyzer, and that GC will be named there DGA, dissolved gas analyzer. That GC will use some refinery gas, that is called RGA, refinery gas analyzer. That GC is called NGA, natural gas, means LPG peoples. They are using that GC will be named as NGA, natural gas analyzer, LPG analyzer. When unnatural resources of power sector, when they are using maybe biogas, they will call BGA, biogas analyzer. MFA, milk fat analyzer. So many applications are there. Same GC with different hardwares and columns. GC will be same, basic GC will be same, and the detectors will be different, and this configuration, valves, tubings, columns will be different.